Today we'll be finding the integral from 0 to infinity of cosine of x over 2 divided by x squared plus 1 dx. And to start off, we can consider the function f of x equals cosine of x over 2 divided by x squared plus 1. If we plug in negative x, we have cosine of minus x over 2 divided by minus x squared plus 1. We know cosine is an even function. We have cosine of x over 2, and minus x squared would just become positive x squared plus 1, which is equal to f of x. Since f of minus x equals f of x, we can conclude that f is an even function. So we could therefore write the integral from 0 to infinity of cosine of x over 2 divided by x squared plus 1 dx as 1/2 the integral from minus infinity to infinity of cosine of x over 2 divided by x squared plus 1 dx. And now we could construct 1/2 the integral over the upper half plane of cosine of z over 2 divided by z squared plus 1 dz, or 1/2 the real part of the integral over the upper half plane of e to the I z over 2 divided by z squared plus 1 dz. And z squared plus 1 is the same thing as z plus I times z minus I, or we have z equals I or z equals minus I, but only z equals I is contained in the upper half plane. So we could use the residue theorem at this singular pole, which is 1/2 the real part of 2 pi I times the residue of e to the I z over 2 divided by z squared plus 1, where you evaluate this from z equals I. So this is equal to 1/2 the real part of 2 pi I, the limit as z approaches I of z minus I e to the I z over 2 divided by z plus I times z minus I. You can notice that the z minus i's cancel, and we're left with 1/2 the real part of 2 pi I, the limit as z approaches I of e to the I z over 2 divided by z plus I. So this limit will evaluate to 1/2 the real part of 2 pi I times e to the I times I over 2 divided by 2I. The 2's cancel, the i's cancel, and I times I is -1. So we're just left with 1/2 the real part of pi e to the minus a half power, or 1/2 the real part of pi over the square root of e. The real part of a real number is just the number itself. So we're left with pi divided by 2 times the square root of e. So now we could say, therefore, the integral from 0 to infinity of cosine of x over 2 divided by x squared plus 1 dx is just pi divided by 2 times the square root of e. And this is the final result. Thank you very much for watching.